Hello everybody and welcome to your video notes in 8.5 at the extends level. And for this one, we're going to do combination circuit calculations. So the basic level was just doing the calculations when it was just series or just parallel. And meets level was finding the total voltage and current and resistance for a combination one. And now the extends level is going to be calculating the voltage and current at each resistor. So if you want to, you can fill out a table like this, or not. I think using a table is nice to organize all of your things. And so you'll notice that this is the same circuit that we had at the meets level. And you'll see why. So the basic idea is we're going to use the total values to find the individual values. So step one, we need the total current, and because of that, we'll need the total current. Typically you're gonna find this at the meets level already. So usually we'll just take our answers from meets level and then just go a step further for extends. And then the last thing we'll do, we're going to use our knowledge from basic level to go backwards to calculate everything individually. I know this saying going backwards sounds confusing, but I'll explain what I mean. So this is our starting circuit. And then we went to a simpler circuit. And we had this. We had our 120 volts here. This was 200 ohms. This was 500 ohms. So we went over this on the meets level. If you're not sure how we got that, go back and check your notes on meets level. But we're going to want to make sure we have each of these circuits drawn. And then from there, we simplified our parallel. Simplified the parallel portion down into that. So this is still 200 ohms. This is still 200 ohms. And then we said that this was 500 ohms. Just kidding. This was 100 ohms. And then the last thing that we had was still our 120 volts for a battery. And I didn't draw this at the meets level, but we could have just redrawn this and said that our final resistance here was 500 ohms. Okay? So that's step one. We already did that in a previous video, so I'm not going to go over how I got these things. If you need to, go back and check that out. So we've got that step done. Now we're going to go backwards and calculate the individual values along each of these steps, going backwards. So we're going to start here, and then we're going to go this way. So, and I did this in the video previously, but I'm just going to do it again. So if we want to know what I is, we know that I equals V over R. And so we get 120 volts divided by 500 ohms, and we get a total current of 0.24 amps. Okay? So because of that, we know that since this is series, that I equals 0.24 amps for each of these. Okay? If I know what the current is here, and I know what the resistance is, I can calculate the voltage. So the voltage will equal I times R. So then I have to do 0.24 amps times 200 ohms. And I end up with 48 volts here. I end up with 0.24 amps times 100 ohms here. And I end up with 24 volts. And this resistor is the same as this one. So I end up with 48 volts because I did 0.24 times 200. So I got that. Okay. And then I'm going to go from here to there again. And I'm going to write down the things that I know. So I know that here I equals 0.24 amps, 0.24 amps. We said 48 volts. 48 volts. Now here, I know that since this is parallel, voltage is the same. We'll zoom out a little bit here. And I know that my voltage here is 24 volts. So I know that V equals 24 volts here, and I know that V equals 24 volts there. So now I can calculate the current for these, because I equals V over R, remember?
Mr. Beza,
Sorry about that. Okay, back to it. Where was I? Yes, V over R, and for this, that would be, my pen works. My pen's not working. Hold on. Okay, I'm back and my pen is working. No more interruptions. Here we go. The voltage here was 24 volts we just decided, and the resistance is 125 ohms. And my 24 volts divided by 125 ohms. So then my current would be 0.192 amps. And then over here, 24 volts divided by 500 ohms should be something smaller, and it is. I get 0.048 amps. Okay. And then we're going to go back another step. Nothing's changed here. This is still 48 volts and 0.24 amps. Now this one's split and this one's split, so those will change, but this one is the same as I just had this previous one. So this one would be 24 volts and 0.192 amps. And now for this one, we know that the total voltage, well, we had the total voltage, but we know that in series, I is the same. Okay, so we're going to take this number 0.24 amps, 0.24 amps, and this number and we'll use that to calculate the voltages there. So for this one, we've got V equals I over R, 0.24 amps divided by 100 ohms. And we get, wait a second, that's not right. V equals I times R equals 0.24 amps times 100 ohms, and we get 24 volts. And we get the same for this as well, because they're identical. We get 24 volts for that. And then over here, we get 275 ohms times 0.048 amps. We get 13.2 volts. And we get a total of 2.8 volts. Whew. All right, so if we zoom out now, do some highlighting. So we calculated the current and the voltage for this one, current and voltage for this one, current, voltage, voltage, current, voltage, current, voltage, current. So there we go. So I suppose you could leave it by itself over there, but I'm going to ask you to kindly put all that information into a table like this one. So for the first one, we said that we've got 0.24 amps and 24 volts. And then this one, we've got 0.24 amps and 24 volts. And then for number 3, it's this one. Got 24 volts and 0.192 amps. And then for number 4, that's this one. 13.2 volts and 0.048 amps. And then 0.048 amps and 10.8 volts. And then lastly, 48 volts and 0.24 amps. There we go. So I'm going to put up one more example here. Okay, this is the one that we had, the other example that we had at the MEETS level. I changed that to be 45 volts. And go ahead and do this one and try it on your own. And then I'll show you my answer. All right, here's what I got for my answers. You can pause it and check your answers, but I started all the way down here. I got my current from the MEETS level problem. And then I went back here and I knew that that current would be the same for each of these. So then I calculated each of the voltages. And then I went back this way. And these I just rewrote because nothing changed. But here, I knew that the voltage had to be the same since they were in parallel with each other. So then I calculated the new currents for each of those. And then I went back to my original problem. I rewrote this one. So this one I just rewrote. This one I just rewrote. And then these ones were series, so I knew that their currents had to be the same. And then I used that to calculate their voltages. And these two are the same. Here's what I got. Thanks for listening.